Okay, good morning everyone. Today I'm going to talk about section 4.5 Newton's second law, which is the most important, formula for physics, which is F equal ma. You probably heard about it. And even though the formula is very simple, you will see it, includes a lot of information and the concept in it. Okay. So the Newton's second law, again, is very simple. Sometimes we express that equation in terms of A, but, more famous version of this equation is F equal ma, right? So, and then F is a vector, and then A is a vector as well. So then, but here, in general, this is a simple version of a Newton's second law. But if we investigate more about this equation, you will see this F is not simply F. You better to call it F net. F net here means the sum of all forces acting on the object. Okay, so in other words, again, if you rewrite it, you can say this is a F net is a M A vector. Or you can say F net again is the sum of the all forces. So sometimes we call this one F, sigma F. So which means it's the sum of all forces. So first question, you have a constant force cause an object to accelerate 4 meter per second square, right? So that means your F, let's call F is the constant force, and then the object's mass is m. So then you can simply have the relationship F equal m times a here is as a force, right? And then the question is, what is the acceleration of the object with the twice the mass that experiences the same force? So then the second case is you have the same force, but now your mass is 2 times, and then what is your acceleration? So then your acceleration must be half of it, right? So the answer is B. And then next one, an object when pushed with the net force F has an acceleration 2, similar question, right? Now, on object, so you again have a F equal M times a 2. This is the first condition, right? Now, twice the force, so that means now you increase the force twice, is applied to an object that has a 4 times of mass, and then you're looking for acceleration, right? So then what should be, so here, from here, you can already find the F over m, the ratio acceleration is a 2, right? So then if you divide both sides by 4m, you will see for m, which is a 1/2 times F over m. And then you see here F over m is a, so this is a 1/2 a. So this is a new acceleration is a half of the original value. And then the acceleration was 2, so your answer is a half of it, which is 1. So the concept of acceleration, and again, acceleration is a vector, right? So basically you can have a two, assuming you have a two forces acting on the baseball, with the basketball here, then you have a two different acceleration. This, acceleration due to this D force, and then acceleration due to this W force, right? So your F net is again the vector sum of these two objects, and then you learn how to add these two vectors, right? So graphically, this is your vector F net, right? And then what is the direction of the ball acceleration? So you see F net vector is a vector times m, right? So that means a and f has the same direction. So f, a, and has the same direction, right? So to the south east, right? And 40 car trains along straight track 40 mile per hour, right? So you have a train and traveling with a 40 mile per hour, right? A skier speeds up as she skis downhill, on which is the net force greater. So the train, the skier, and the net force. So first case, this is a train case. For this case, what is acceleration? Acceleration is zero, right? Why? Because the object is moving to the constant velocity 40 mile per hour. So there's no velocity change, no force, acceleration, same. But if you have a skier actually travel along this line ramp, right? And then it will speed up, right? So another definition of the very fundamental definition of acceleration is what? Delta V over T, right? So if you have a velocity changes, then you have a non-zero acceleration, right? So the answer is a skier. And an object on a rope is lowered at a constant speed. Then what is true? Constant speed. So that means delta V is a zero. So delta V zero, then acceleration zero. So acceleration zero, your net force zero as well, right? So then now you have to draw the force diagram, right? What is the forces acting on this, the object here? So tension is acting upward and the weight is acting down, right? So your net force is what? Your F net is the tension acting upward and the weight acting downwards. And then you see this is a zero. Basically, you can say this is a MA, right? This is a Newton's second law. But now you see, because A is a zero, you can say this zero. So that means T equals a W, right? So the answer is B, right? Now, this is a little more trickier question. Objects, the same situation, right? So the net force acting on this object is again tension acting upward, weight acting downwards, right? So again, your F net is a tension upward, weight acting downward, equals again MA, again, right? But the decreasing speed, so decreasing speed, what does that mean? Which force is greater? When it's lower, speed is slowing down, slowing down, slowing down. So that means the tension is greater than W, right? Because it's decreasing, right? So then the answer is A, right? And the unit of the force is a Newton, but this is a simple version of the unit, but you can say because force is a mass times the acceleration, right? So the unit for the mass is a kilogram. Unit for the acceleration is a meter per second square. So the unit for the force is a kilogram meter per second square, and we call it Newton. Now it's the combination of your chapter 2 and chapter 4 here. You have a small airplane, sits at rest, and the mass is a 51,000 kilogram, right? The pilot turns the pair, so that means you have two engines, and then the thrust accelerates plane down to the runway. After traveling 940 meters, right? So the distance from here to here is 940 meter, which is corresponds to delta x, right? The plane reaches its takeoff speed 70 meter per second. So now you see initial velocity is zero, and your final velocity is a 70 meter per second square, right? So basically you have a three, one, two, three parameters. So this is actually what you did for chapter 2, right? So you have three parameters and you're looking for what is the acceleration. You can find what is the acceleration, right? So your acceleration, in order to find your acceleration, you have to find the equation where delta x is not involved in here, right? So then you have the V final equals V I t. No, so t is not here, right? So you have to find the equation that doesn't have a t here, right? because you can also find t if you want, but let's find the acceleration first. Right? So then you have to use the 2ax delta x is at 940 equals to v final square, 7 square minus a 0 square, right? So then you can find the acceleration will be 2.6. So then now, because you know what is acceleration, right? Your acceleration, again, your force, net force, is a m times whatever acceleration 2.6 you find here, right? So then you can find the net force, right? By engine, right? And then because you have two engines, whatever you got for net F, half of it is powered by thrust by each engine, right? So then you see this number is 133,000, and then for one engine, it's a half of it. Okay. And then free body diagram is, we already talked about the free body diagram, right? So we'll go more details about this free body diagram next time. Thank you.